Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with design of concrete elements in the topic of behavior of reinforced concrete members in bond and anchorage. Okay, so now the problem will be check for the bond stress at the point of inflection of the continuous beam if it is subjected to the ultimate shear force of 300 kilonewton. At the point of inflection, consider the concrete grade is M20, then steel grade is Fe415. Okay, so now we have to check whether the point of inflection within the safe limit or not. So now we have to ensure the anchorage length of bar for continuous beam is, so that is development length is less than or equal to mu divided by vu, that is moment, ultimate moment divided by ultimate shear force plus development length. Okay, so now this condition is satisfied, so the anchorage length is within the safe limit. Okay, so first thing is we have to find out the development length. After that we can find out the ultimate moment, so then apply to this condition, so whether this condition is satisfied or not. Okay, so now the given values, so that is vu is given, that is 300 kilonewton. So then Fy value is given, so Fy is 415 Newton per mm square. So then FCK is 20 Newton per mm square. Okay, so these are all the values given. Okay, so now we can take the development length LD equal to 5 into sigma S divided by 4 into tau BD. Okay, now 5 is the diameter of the bar, then sigma S value is stress in the steel bars, and then tau BD is design bond stress. Okay, so now we can take sigma S for the continuous beam, so now we can take 0.87 into Fy. Okay, so now we can substitute all the values over here. So the phi is given, that is 16, the 16 mm dia bars, into sigma S values 0.87 into Fy is given, that is 415, divided by 4 into tau BD. So tau BD is 1.92. So for deformed bars in IS 456 we can take 1.92 Newton per mm square. Okay, solving this we got the value of 752.19 mm. So the development length LD is 752.19 mm. Okay, so next thing is we can calculate the mu, that is ultimate moment of resistance of the section. So now before that we can calculate the PT, that is percentage of tension reinforcement. PT equal to, that is 100 AST divided by B into D. Okay, so now we can take the 100 into AST is 3 into 201, that is 16 mm dia bars and 3 bars, divided by B is 230 into D is 450. Okay, so these are all the given values. So 3 numbers of 16 mm dia bars, then B is 230 and D is 450 mm. So these are all the given values, so we missed to already mention in the problem itself. Okay, so now we can take PT percentage of steel is 0.583 percentage. Okay, so now we can take refer the SP16 code book. Okay, so we all know SP16 is reinforced concrete elements code books. So in the SP16 table number 2, for Fy equal to 415 Newton per mm square, so the corresponding PT 0.584 percentage, so mu divided by BD square value will be 1.85. Okay, so now we have to find out the mu. So now mu equal to 1.85 BD square. Okay, so now mu equal to 1.85 into B value is given, that is 230, and D value is given, that is 450 square. So now solving this we got the value of 86.16 into 10 power 6 Newton mm. So now we found out the LD value. So now we can substitute all the values over here. But the thing is, we have to consider the LD. So that is development length. So LD is depth, effective depth, or 12 into diameter. So this is the whichever is more, we have to take the development length. So now we can take the, this is 450, or that is 12 into 16. So okay, so that is 192 mm. So now we can take the LD value is 450 mm. So now we can calculate the LD value is 752 mm. So 752.19. Okay, so less than or equal to, moment is 86.16 into 10 power 6 Newton per mm. Here the VU is given in the kilonewton. So now we convert into Newton, that is 300 into 10 power 3 Newton, plus in here is 450. Now 752.19 less than or equal to 287.2 plus 450. Here 737.2. So now the condition will not be satisfied. So now we have to increase the depth of the beam. Okay, so after the increment of depth of beam, that is 500. So the condition will be satisfied. Okay, so this is a method we can solve the problem. Again, we'll see next video. Thank you.